Hello, today we are trying to demonstrate how to use the Autodesk Robot to model a composite structure with a concrete column and a concrete beam and concrete shear wall and concrete slab at the in the ground floor, and in the first floor we have a steel column, steel roof beam, and a balcony in here. Okay, so the structure is subject to the dead load, the self weight itself, and then some additional dead load that may be caused by the equipments or the self weights of the partition walls or these things we maybe need to consider, and also subject to the wind loading and snow loading. So let's have a look at the structures, and then trying to demonstrate how we model these structures in Autodesk Robot. So I'm not going to read through all this information one by one, and then you can have a detailed look yourself by print it out before you start. And then also in the demonstration, we're going to give you some more details as well. So let me zoom. Sorry, no, let me minimize this that Word file, and then which you can download from the Moodle, and then we can start the modeling. So to model these structures, we start from a 2D structure first. So first we click on New Project, and then this time let's do it in this way. We do it in 2D. We model these structures step by step, and in 2D, and then we enlarge or convert it into 3D structures. Let's use a 2D structure to start with. So I click on 2D frame structures, and just in case somebody hasn't seen clearly what I have clicked on, so make sure you click this one. Okay, you click on this one, and then you have this windscreens which allow you to create the structures from scratch. So the first thing we need to do is define the right coordinates for the axis. So you can generate the building axis in the right position, so we can draw out these structures one by one. And then let's try to do this one by click on this button. So we bring back this screen which allow you to define the position for each axis. So let's do this one by one. So the first coordinates that we want to put in is the x coordinates to generate the x axis for this one. So the x axis, what we have the first one. We start from the -1, so we need to remember we put in the -1 in here from -1 meter, and so we have only one repeat. And so you can, if you have a look at the building here, start that the x is from -1 and into 1 meter, and so on and so forth. So let's have a look at this one. So -1, 1 meter, and then 1 repeat, and then second one will locate in the original line, which is 0, and then the next one we're going to that repeat twice. So let's put in 2, and then each one is 7 meter. That's 7 meter that the bay you have for this one. So we add on this one, and then the last one is a balcony. It's 1 meter. So balcony stick out this one for 1 meter. So and we can put in 1 meter in here. So we put in 1 repeat, and then so the last one is a 1 meter. Add on it. So the x coordinates is complete. So the next one is z coordinates. So z coordinates, we start from 0, and then the first floor is only 1 repeat, and then in 4 meter high. So you click on add. so you got maybe make one mistake. So this one should be one repeat, and then one repeat 4 meter. So this is going to be 4 meter, the second one, and after that we one repeat again, and but raise up by 3 meter and add to it, and then so 3 meter, so which means that so 4 meter and then 3 meter now is this height and here. And then the next one is going to be the 1 meter up a little bit to create the second to create the second pitch point. So the next one is 1 meter higher to create the pitch loaf. So will be one repeat, and then here is 1 meter at, so that's 8 meter. So that's going to be this point here, and then after that 1 meter higher to create another pitch loaf. So so that will be 1 repeat again and 1 meter, and then click on add. So that's the next level done. So once this done, then you can click on apply, and then you got the structures generate in here ready. So let's close this window, and then we can start to generate the structures. So before we generate any structures, and then we need to define the different members we're going to use in our cross section. So as we said, we use the concrete bins and then steel bins. Let's do this one. So I already create this one here, so I delete them one by one. So if you don't have this one, you don't need to do this step because I done this one before. So all this bin has been selected. So let me delete all this one, so make it easy for you. So you possibly don't have anything, or you have something not the one we want, but it doesn't matter, you can leave it on. And after that we can create a new element. So the first one, let's create a RC bin, RC column first. So the RC column, we can that create the first one is the RC 300 by 300. So this is the column, and then the height and the breadth of the bin is 300 millimeter. The other one is a 300 millimeter, and you click on add. This bin has been generated in there, and then also you change this one to RC bin, and then so the label will be RC bin, and then 300 times 600, and then so the height of this one is 600, and then the breadth is 300. So once you click on and then add, you create these structures already. So after that you can convert back to the steel. So we need to choose the proper beams for the steel. So the bin we're going to use, no matter whatever you click on here, doesn't matter, but the section you need to choose the family in here has to be the first is the column, the university column. So the university column, as we said, we use the universal column 203 by 203. So 203 by 203 by 46. So we use this one, and then you click on add. This column will be selected on. So for the beam in one direction, we use a UB. So one direction we use a 254. So it's a 254 times 146 times 31. So that's for the pitch roof. You add on this one. And then another one is the one to connect the panel later on together. So we can maybe leave it on later on. So we don't need this one yet. So let's leave it on. So this is all we need to create this one panel structure. So once done, you can close this structure and then close this down. So the rest things I think are pretty easy for you to do. So we need to create you have done this many times already. So let's create the column first. So that will be the RC column, and then that's the dimension we have defined. So we can choose from this one up to here, the first one, and second one from here to here, and third one from here to here. Okay, so column is done, and then so the next one is the beams for the RC beams. So we can have this one by RC beams. That will be the RC beam 3 by 600. So 600. So we start from here to here, and here to here. Another one from here to here, and the balcony then stick out from here. Okay. So this structure has finished. That's ground floor. That the floor is the concrete structures. So on top, we will have a column continue to build up, which is the universal column, which we choose from the section property table already. So we have one column here. So we build up from here to here, and then another one is from as we said, we're going to connect one pitch loop from here to here, and another from here to here. So this must be a segment in here. So we need to connect from this point to this point, and then continue from this point to this point. Okay. So the other one, the column in here is from this point to this one. So we continue to draw this one from here to here. Okay, so that's column done for the first floor. So we need to build the next one is the beam, and then the beam, as we said, we use the 254 146, and then times 31. So the first segment of the pitch loop will be from here to here, and then the second one is from here to here. Okay, so once done, we can close this window, and then as we learned before, we can have a look at the structures by click on this section shape in here. That's going to show you the shape of the building, and then you can hold on the shift key and use the scroll bar and rotate to have a look at the structures that you just create. So once you're satisfied with the work you have, and then you click on view, and then you click on the XZ, will bring back to the original drawing phase for you. So the next one we need to do for these structures is that we're supposed to put the support at both ends. So we can click on this one and put a support on, which is going to be fixed. So we fix in here, fix in here, and fix in here. The three are fixed connection. So we close this part. And so the next step, we need to apply the loading to these structures. So the loading we're going to apply, we need to define it several different case. As we said, we have in one panel. So in one panel, we have the dead load, which is a self-weight. So we create a dead load one. That we don't do anything, the self-weight will automatically, so no loading apply in the dead load case 1, so dead load case 1 only will be the self-weight. And then the dead load 2 case will be UDL put in here, supposed to be, say for example, a brick wall built on this one, so that was the loading we're going to apply for the first floor beams. So the beams we have the dead load that is subject to 10 kilonewton per meter. So going to be the loading we apply 10 kilonewton per meter distribute on this bin in here. So we're going to apply this one by one, and then we have to summarize, we have dead load, and then dead load case 2, which is the brick wall, and then we also have a point load apply at the middle of this two beam, 20 and 30 kilonewton each one, and then maybe some that the equipment has been located in this position, so that they do have a point load located in that location. Also, we will have the wind loading apply in this panel, and wind loading on the pitch roof, and then snow loading on both as well. So this is something we need to consider. So once we got these structures, and then let's coming down to have a look at the structures we have in here. So the next one, let's maybe continue to generate the load type. So to generate the load type, what we need to do is that you need to create, click on this button, which is in here, to open up the window for you to allow you to create the load type. So as we said before, so the load type one, you just choose this one as dead load, and then the type natures is a dead load, and then the name don't need to change, dead load one, and then you add on this one. And remember, later on we don't add any loading to the dead load one, so this dead load, because without any loading applied, so it will only include the self weight of the structures, so that's automatically calculated by the computer. And then we also need to add another one, which if you click again, that's going to be the dead load case 2, and then dead load case 2 we will apply the dead load on the on this concrete bin later. So we have also the live load, which is applied in the middle in here as a live load, a point load applied to the middle. So let's do this one in here. So that's going to be the live load. So we change this one to live load. So that's going to be live load 1 we're going to apply. So that will include the 2-point load in the middle. And then also we will have wind loading, and then apply to these structures. And then also we have the snow loading as well. So we have a snow loading as well. So once you done this all that load and live load, so you just need to close this window, and then we are ready to apply the loading. So to apply the loading, so the first you use the next one, the load definition. So click on this button, load definition, and then you click on bar, so allow you to apply the loading to each bar. So we use the distribute load, uniform distribute load. So for each bin, as we said before, you have minus 10 kilonewtons that loadings applied to each structures. And then so we not use the project load, so we use a global, and then apply directly to Z direction. So we click on add. So once this one add, and then you can apply this loading one by one. So this is one segment, second part, third part, and then the balcony as well. So that's the loading you apply. And then oh gosh, I make mistake in here. So I do need to delete this loading, because what happened is that I changed to I noticed I forgot to change this one to the that load 2. So let's move our cursor to here, and then what you can do is that you can right click on this one, and then you can click on delete. So this loading been delete, and then again, and then click on delete, and then yes, sorry, I delete all this loading. And then because the other loading possibly hasn't been deleted yet, so I need to bring back this load definition. So once you click on this load definition in here, so this loading's been come back, and then you can see this loading in here. So or the other way you can do is that you can switch to the load mode. So switch to load mode, and then in this screen, if you move to the SN1, so all this loading is still there, so you can delete them one by one. So you right click in here and delete, and then they ask you only delete for indicated ones. Oh yes, okay. And then this one, another one, click on delete, and then click on, make sure you click on yes, and then this one, delete this one, and then okay. So all the loading changed. And then the most important thing is that you need to make sure you highlight the low case 2. So all this loading you apply now is going to belongs to the low case 2. So click on this one again, we do again. So that the download -10 is still there. So we click on add, and then at this time you add on. Now you can see the low case is going to be activated to the that low case 2. So this is one is the that low case 2, and then but of course this one you should be able to change to the that low case 2 as well, but not necessary, because in here you already activate this one as a that low case 2. So all the loading you apply is going to be the that low case 2. So let's put the loading on here, and then here and here. So that's the low case you have in here. And the next one, what we trying to do is the live flow. So the live flow, as we said, is on the middle of the structure here. So this is 20 kilonewton, this is 30 kilonewton. Let's have a look. Is it right or not? Yeah, 20 and 30 kilonewton in here. So then we highlight this one, and then we click on low definition, and then this time we use this one to change the that low for this one. So first one we put in the -20 kilonewton, and then and then you choose the relative. So the relative means you use the x coordinates. If give you 0.5 means you locate in the middle of the beam. So that's loading apply in the middle of the beam. And otherwise you give me how many distance away from the starting point, and you can use absolute value, and then you can key in the actual values to put this point low. So what I can do is that once this done, 20 kilonewton, that's correct. You click on add, and then you come back here to select the bin in here, so the point low is applied in the middle. And then so the next one we change this one to 30 -30 kilonewton, and then let it equal to half. So that's going to apply to this location, so slightly higher than this one. Okay, so once we done this one, and then the structures that low and live low has complete, and then we next one we're going to put in the wind loading. Wind loading, as we mentioned before, the ground floor has 1.5, and then the 2.5 and 3 kilonewton. Excuse me. Excuse me. So the wind loading, the ground floor is 1.5 kilonewton. So let's apply this one by click on the low definition, and then the bar, and then click on the uniform distributed load, and then that should be -1.5 kilonewton per meter. And then it's in global direction, and oh sorry, it's not this one. So there's the in global x direction. So let's put in here -1.5 in here. And so once you finish, you click on add, and then after that you're going to apply this loading to these structures. Then you can see the loading is a long direction, is should be the 1.5 direction, so it's not negative. So because x direction, this is positive. So you can either delete this one, apply and change again, or the other way you can do, you can change this number, because this one is showing in here. So you can delete the minus, and then keep the 1.5 and press enter. So the loading will transfer to the other direction. And then the next direction of this one is a 2 kilonewton per meter, and this time what we can do is that we can show you can apply the loading another way by using the local coordinates. So using local coordinates, we put in -2.0 kilonewton per meter, but in z direction. So the local coordinate z is perpendicular to this one, and then we can give it a local like that. And then after that, if you're happy, you can click on add, and then apply the loading in here. You see the loading is applied along this direction, but in global local coordinates. So the last one is the roof window. For the roof window, as we said before, is a 3 kilonewton on top, and then it's perpendicular to the roof. So what we can do is that we can use the same method in here again and use a bar and create this one. And then this time is minus 3 kilonewton, minus 3.0 kilonewton per meter, and we use the local, and then because it's a local z direction will be perpendicular to this direction, so this is the x y direction, x direction in local, so z direction will be always like this way. So then you can click on add, and then if you apply the loading on this one again, you can see this one is perpendicular to this roof, so that's the wind loading. The wind pressure is always perpendicular to the roof. So if you want to have a look at the values of each loading, you can actually click on this low value descriptions, and then he will bring back the loading for you as well. So the next one is the snow loading. The snow loading, as we said before, we possibly forgot to delete this one, because when we click on this one, and if you notice there was a uniform low, that low on there already, so we need to maybe remove this one. So by right click on here and then delete this one. So not delete like this. So let's highlight this one and then press the delete key, so that loading has been deleted. So you can also have a look at the loading one by one, and then to find out whether there was some loading still included in there, but should not be. And so the snow loading will apply to the roof only, and then the slow loading is actually 2.5 kilonewton per meter. So we can add this loading in here, and then it's bar loading, and then the snow loading is the this part, and is minus 2.5 kilonewton per meter. And then this time, because snow loading will be vertically applied, and then it's also projected load on this roof in here, because that roof is calculated by the height of the snow in here. So you have to use the project load to calculate the snow loading, and then after that you click on this one, so this loading is applied in here, and then this loading is applied in here. So if you click on this low value, you can see it is a 2.5, but it's projected load on the roof. So all this loading has been complete, and then now we can continue to the next step. So the next step is trying to convert these structures to the 3D structures. So to convert this structure to 3D structure, let's maybe first to change this structure mode to start first, which bring back this structure in here. And then the next one, what we're trying to do is that we need to add a different structural type in here. So to add this structural type in here, we're going to use a structural type under this geometry tab, and then click on this one, and then it will allow you to add on what the structural type we have, because we have the shear wall and the slab later on, so we have to use the shell structures to include in this one. So let's click on these shell structures, and then before we do that, it will ask you, do you want to save this file? Yes, I do want to save this file, just in case I make some mistake, and then I replace my original structures already. So after that, because as we said before, we want to create a 3D axis, and then we need to add on y direction now. So we click on this button and bring out this window structural axis, and then the y direction we do have three bay three panels of this wall to create a building. So the first one is 7 meter. So actually is that's create a two bay of 7 meter each, that 40 meter in total, this building. So once you finish, you click on add, and then you click on apply, and then the structure has been generated. The structure axis in 3D has been generated. So we click and we close this window. So once you create this window, then you can create. You can click on here and then bring back a 3D view. So that's going to be. Oh, why is not 2D, 3D, and let's close this one. So I don't use this one, so I don't know what's wrong with that one. So we can use this global working, oh, not this one, 3D view. Possibly it's better use this one. Okay, so click on this one. So you click on this button and then bring back this 3D view. So this gives you the 3D view of your structures, so which have generated already. And then the next one, we need to copy this one. So this identical frame going to be 3 panels of it. So what we can do is go to the edit and then go to the edit and then move and copy. So once you come to this point, as we said, is 7 meters away from each other. So you can dot and 0, 0, comma, 7, comma, and 0. Oh, sorry, type wrong. So 0, comma, 7, comma, and 0. The numbers repeat is 2, so we have 2, and then copy this one. So if you click on execute it, and then oh, sorry, so maybe I need to select all the structures. Let's click on yeah, do you want to perform this operation for the whole structures? Yes, you can click on yes. Or the other way you can do is that you can, if I click on no, say if you can click on yes, will be the same result. And if I click on no, let me try to do it this way. I close this one, don't do this one first. So that's selecting mode. So what we should do is that you can select whatever you like to move, and from here to wherever you want to copy from here to these 3 location, to these 2 location, then you select all this one. And then after that, you can then go to the edit, and then move and copy. Same thing again, will be 0.7.0, and then copy, and then to repeat, and then execute. So the structure has been created already. So you see these structures has been created in here. So what we need to do is that connect this pin together to form structures. So to connect these two, so the beam to connect this roof is a different one. So we need to pick up this one from the database. So we use the bar sections, bring up this window, and then create a new bin cross section, and that will be the universal bin, and then that will be 203 times 133, 203 times 133 times 25. So we add this bin to the list, which is add to there already, and let's close this window. So that's the one we want, and then we close this window, and then after that we create a bar, and then this time make sure you select the beam in here. So the cross section is 203 times 133 times 25, and then after that you link this beam from here to here, here to here, and top one maybe not easy to see, so you twist a little bit in here. So let's connect from here to here, from here to here. Okay, so from this one again is the from here to here, here to here as well. And then after that is going to be this one from here to here and here to here. Okay, so once done, then you can click on close. So that's the new structures you generate. And then I think possibly we make some mistake in here. Let's see whether the building we built, yes, there was no connection in here. here in this 3 direction. So we possibly need to delete this one. We may not need that one because it's a very close and very short radius, so this may not necessary to connect that rigid one unless it's necessary, and then may not need that one. So let's delete these two. So we delete this one, and then let's select this one, delete this one as well. So this bin has been deleted. And then the first floor, the floor in here, we're not using the steel bin to connect, and instead we use the slab to connect this. So to connect the floor with the slab, we need to use a COM2 to generate these structures first. So to enable us to do that, what we're going to do is we need to select a work plane along these cross sections. So let me click on here, and then we have a 2D plane, and then the 2D plane we are looking at the XY plane, and then the location we want to draw this slab is 4 meter above the ground, so we select the second one. So we're going to draw at that location. So once this done, then you can click and close this part in here, and then you use the polyline, create a contour. So we start from the one of the 4 corner, this one to here, and then here to here, and here to here, and then come back to original point. So this contour has been generated already. So this contour 49, and then after that you can click on the panel, and then the thickness you can double check. We can create one thickness which is the that equal to, say for example, that 30, and then this one can be 300 millimeters, and then click on add, and then close to this one, so you can see this thickness has been set to this one. So the reinforcement is set to none first at the moment, and then once this settled, and then you move your cursor back here, and then click on the middle of this one. So this plane has been generated already. So once you generate these structures, and then you can hold on your shift key and rotate to have a look. So this is the floor slab has been generated already. So our next step is going to, what we're going to do is that if you have a look at the details of the slab in here, so you see the concrete beam is actually at the centers. The slab is actually in the centers of the concrete slab, which is not a normal design. The normal design, the concrete slab is going to be lower down, and then supporting the bottoms of the slab instead. So we need to offset this concrete beam, and then drop this one down to the bottoms of the slabs. So how we do that? So we use the offset function to do that one. So offset function, I think you possibly saw the icons already, but you maybe haven't used this one before. That was the icons in here. So we can actually set the items, and then the offset. I already generate this one, so I delete this one in here, and then let's do the new offset. So this offset, what we need to do is that we need to define how much offset you want to do. So the offset of this one is actually from the center. So this bin, the top of this bin, will move down to the bottoms of the concrete slab. So they move maybe half of the beam, which is 300, and then plus another it's a 300. So because the beam is 600, so half of the beam is a 300, plus half of the concrete slab is actually is the 150. So in total, 300 plus 150 is 450. So this is going to be moved down 450 millimeter in millimeter, and then both this end the bin, and this end the bin, they both move down the same distance. So that will be minus 450 as well. So the coordinate system is in global, so they're going to move down in z directions in that minus 450 that direction. And then the labels of this one you can give it to the offset 1, and then that's a given name to it. So once you click on add, so you can see on the back of this window, this offset has been created. So let's close this one. So now we want to apply the offset to this one. So it will be quite difficult. We click on this one by one and then select then and then offset then. So there was another way to do. Let me show you how to do this one more easily. So we can use this icon, which is the bar selection function. Say click on bar selection, and then once you click on bar selection, and then you can select by section, you can select by the structural object and by name, by whatever it is. So the one just coincidentally all these pins in one single type of section, that was the RCB 300 and 600. So once you click on this one, and then you can click on this button, and then this button will select every bin with this cross section and put their the list on here. So once you done this one, you can close this window, and then now you can see this bin has been selected and highlighted. And then if you come back to this window in here, which is showing current selection, you click on here, and then he will copy whatever you have selected and put in here, and then you just simply click on apply, and then this bin now is moving down to the bottom. So because we close the offset window, this one is disappeared again. So actually you can set this one to show this offset by click on this button in here, again this button in here, and then you take this offset, take the offset, and then click on apply, and then OK. You see the concrete slab now is on top of the concrete bin. So that's normally the normal design you can see. Okay, so now this structures this has. So once this slab has been done, the next structures we need to create is actually the shear wall, which is a concrete wall at this location. So to do this part, what we need to do is that we do need to use a 2D again. So this time the 2D we use not the let me think, it's not the XY, should be the XZ, right? No, not XZ, so it's a YZ, so it should be YZ. This is front view of this one, YZ direction. So it's a 2D YZ, but we are the bin is going to draw on the 40 meter away at the X direction. So you need to choose this 14 meter. So which means it's actually this panel, okay, this panel in here. So that's 14 meter away from the X direction. So let's do again. It's a 2D YZ direction and then 14. So close. So that's actually the structures we're going to the panels we're going to draw the shear wall. The shear wall only located in the ground floor, okay, not the top one. So because top one you have maybe have a big window, and then this balcony you can walk out from here. So to create this shear wall, which is located in this area, we can use the coordinates I given to you before. So using these coordinates that given in here, you can generate this one by one. So let me show you how to do. So the first one, the first thing you need to do is that use to generate this contour by click on this one, and then the first corner is start from here, which is, if you look at this one, so the coordinates, if you move back here, is 1400. So if you look back, the coordinates is 1400. Okay, so the second one is 1420. So which means it's 1420 is this location, and then the next one is the 1423. So 1423. So go up. The door is 3 meter high. So go up to here, and then the width of this door is 1443. So actually it's a 2 meter. The door is a 2 meter, 1443. So let's come back here. So 1443 is this location in here, and so on and so forth. That I just continue to do this one. So next opening is here, and then here, and here, and here, and come back here, and top to this part, and come down to here, and that's it. So this is the contour been generated. So we need to fill this contour with a slab. So we use this one in here, and then this time this thickness is going to be changed to the 250. So it's a 250, and then the name of this one is given to 250 as well. And then once done, and then you can click on add. So you can see once you add and you modify, and then you can select the proper 250 in here, this cross section in here. So this reinforcement we should select none, so make sure it's none. And then once you done this one, and then you click on the middle point of any area in here, so this this shear wall has been generated. So if you have a look at these structures, they can use hold on the shift key and use a scroll bar. You can see these structures has been generated in here already. So that's pretty interesting to see. So once you generate the floor slab and the shear wall, and then the next one we need to measure it to allow this final element to calculate these structures. So to measure it, we need to use this mesh function by click on analysis tab, and then mesh options. And then he said, no panel, do you want to perform this operation to all panels? Just click on yes. And then when we create this mesh, so we should use the complex mesh generation that functions in here. And then what we need to define is that we need to define the maximum size of the element. So we click on the element size in here. So we define that every element is a 0.5 meter. That's roughly the size of each element. So once this one done, then you can click on OK, and then this mesh has been generated, so applied to all these two floor slab and shear wall structures. And then after that you can click on generate the computational models by click on here, generate the computational model, and then this structure will remesh all the structures. So these structures has been created in here. Okay. As we said before, the floor slab will have 10 kilonewton per meter square loading applied in these structures. So we will need to define this loading. So before we can do any loading, we need to create a new load type, which is a live load 3, so live load 2. So let's change this one to live load 2, and then so to live load, and then if you click on add, so you will create now another new live load in here already. So once we create this live load already, and then we can use the load definition by click on this one, and then click on surface pressure, and then click on this one in here, and then this time we can use the PZ location. So we can use the uniform pressure loads, and then apply in the apply to the Z direction, so in global Z direction, so that's equal to minus 10 kilonewton per meter. So it's 10 kilonewton per meter. Is it K part? Let me do a calculation. for this one. Yes, that is 10 kilonewton per meter square, so minus 10. And then we can click on add in this one. So this loading has been added to this structure already. So we apply, if you select this edge in this loading, so which is uh, the the surface loading in here. So when you select to the proper one, you select the edge 53. So you need to select, you make sure you select the whole area, and then after that you click on add. So this loading has been added to the whole area. Okay, so if you select only this one, only apply to one mesh is not correct, so you need to make sure this one is highlight whole area, so this loading has been applied to the whole area already. So after that you click on close and then close again, so that loading has been applied. Then the next one, before we carry on this part, we better to create a load combination which allow us to combine all this load together. Then you can see the results. So to see this, to create this one, you need to click on loads, and then you can click on the manual combination. So we create a combo one, click on OK, and then so what we need to do is that all the dead load in here should be 1.35, right? So 1.35. So we put in here. Or the other way, you can let this one, the factor automatically choose is 1.3, and then the live load should be 1.5, and the next one, the live load should be 1.5, and then the wind loading should be 1.5 as well, and then the snow loading is equal to the 0.5. As this one, as the snow loading is not leading that variables anymore, so because you combine the live load and the wind load and the snow load together, so the snow loading will have reductions in here. So once done, then you can click on apply, and then the new combination has generated. So once this has been done, you can see all this structure has been created ready, and then you can run the analysis. So you run the analysis by click on this one, calculation. So once this done, so the structure is ready, and then you can ready to have a look at the results. So let's have a look at the results of deformations. First, you click on result and result diagrams, and then you can click on the deformation and then deformed shape. If you click on this one and then click on apply, and then that's give you the deformed shape. And then for the first one, but you can, if you click on the combination, and then that's the deformed shape for you to have a look. And then if you click on normalize this one, so they become a maybe a better view for you to have a look at these structures. And then if you rotate these structures, so that's going to be the deformation of all angle. Okay, so the wind loading and the structures as well. And then let me think, how can I see the only the deformation itself. So if you want to see how this bar was deformed, you can maybe actually select the results that the deformation for bars. So let me see how can I see this deformation more clearly, and then basically let's rotate a little bit. So I want to get rid of the original structures to see the whole deformation. So what you can do is that you firstly can click on this button and this button again, so that's give you the deformed shape. So that's give you maybe a clearer view of how this structure is been deformed in here. Okay, so also you can have a look at the stress, the results in the contours. So if, for example, if I want to have a look at the, so for this one I maybe untick this one. So if I want to have a look at the deformation in UW in Z direction in here, I click on these structures, and then so if I click on with the finite element mesh, and then click on apply, and then that will demonstrate that the deformation of the structures, and then show in contours for this mesh in here. So and also, if you like to have a look at the stress, say for example in x and y direction, you can also tick in this one and then click on apply. So that's give you the different stress deformation, and then so on and so forth. So that's conclude the analysis for this demonstration. Hope you enjoyed. And then so Autodesk Robo is quite powerful, that software, and then a lot of things to learn. If you're interested, you can maybe put more effort to read through the manuals and do some more practice, and then learn that finite element that analysis theory in more depth. So that's certainly going to help you. Bye bye for now.